Have you ever looked up at the night sky and wondered how space shuttles launch into the vast expanse of the universe? It's an intriguing mystery, one that combines the marvel of human ingenuity with the limitless wonder of outer space. The process of a space shuttle launch is a complex ballet of technology and physics, a spectacle of fire and thunder that sends humans beyond the confines of our home planet. In the next few minutes, you'll discover the technical marvel that is a space shuttle launch. Every space shuttle launch begins with a countdown, but have you ever pondered why? We often associate the countdown with the excitement of the launch, but it's more than that. It's a precise procedure, a well-choreographed dance of checks and balances designed to ensure a safe and successful launch. The countdown starts hours, sometimes days before the actual launch. It's a meticulous process that includes numerous checks on the shuttle's systems, from the engines to the life support systems. It's also a time to monitor the weather conditions closely, as they can have a significant impact on the launch. Any sign of unfavorable weather can result in a delay or even a scrub of the launch. Each second of the countdown carries weight, every tick of the clock bringing us closer to the moment of truth. So the next time you hear a countdown, remember, the countdown is not just a dramatic spectacle, but a crucial part of ensuring a safe and successful launch. With the countdown complete, the real magic happens: ignition and liftoff. The ignition process is a beautifully choreographed dance of technology. It begins with the three main engines of the space shuttle, which are located at the rear of the orbiter. These engines are fueled by a mixture of liquid hydrogen and liquid oxygen stored in the massive orange external tank. The main engines ignite sequentially, each about 1 second apart, starting with the center engine. The main engines are ignited before the solid rocket boosters for a reason. It's a safety measure, allowing for a last-minute abort if necessary. You see, once the solid rocket boosters are ignited, there's no turning back. They're like giant fireworks. Once they're lit, they burn until their fuel is spent. About 6 seconds after the main engines ignite, the solid rocket boosters are fired. These two boosters, attached to either side of the external tank, provide the majority of the thrust needed for liftoff. They burn for about 2 minutes, propelling the shuttle upwards with a force equal to more than 12 million horsepower. The liftoff is a breathtaking sight. The space shuttle, a marvel of human ingenuity, is propelled upwards with an incredible force, breaking free from the shackles of Earth's gravity. It's a moment of high drama, filled with anticipation and excitement. This is the moment we all wait for, the shuttle breaking free from Earth's gravitational pull and soaring into the sky. As the shuttle ascends, it's time to shed some weight. So what do we mean by that? Well, let's dive into it. The space shuttle's solid rocket boosters, or SRBs, have a very specific job. They're like the ultimate heavy lifters, providing the majority of the thrust needed for the first 2 minutes of flight. But once they burn out, they become nothing more than dead weight. That's when the shuttle's onboard computers command the SRBs to jettison. Explosive bolts fire, and the boosters are pushed away from the shuttle's external fuel tank by small separation motors. It's a process that's as precise as it is dramatic. This separation happens at an altitude of approximately 28 miles, about 2 minutes after liftoff. With the boosters gone, the shuttle becomes significantly lighter, allowing it to continue its ascent more efficiently. This is vital for reaching the required speed and altitude to enter orbit. Now, you might be wondering what happens to these discarded boosters. They don't just disappear into the ether. The SRBs parachute down into the ocean, where they are retrieved, refurbished, and reused for future missions. This recycling was a crucial part of the Space Shuttle program's aim to be a reusable spacecraft system. The discarded boosters, having served their purpose, fall back to Earth, while the shuttle continues its journey. Now in space, the shuttle's mission truly begins. The shuttle, having discarded its boosters, is now on its most critical journey. It's about to enter orbit, but how does it do that? Well, it's all about velocity. The shuttle needs to reach a speed of approximately 17,500 miles per hour. That's fast enough to keep the shuttle falling around the Earth rather than into it. This state of continuous free fall is what we call orbiting. To achieve this speed, the shuttle relies on its main engines, which continue to fire until just before reaching the desired orbit. These engines are fueled by a huge external tank, the last component of the shuttle that's still attached. This tank contains liquid hydrogen and liquid oxygen, the two components needed for combustion. Once the fuel is depleted, the external tank is jettisoned and burns up in the Earth's atmosphere. Now, with the shuttle in its desired orbit, the main engines are shut down, but the mission is far from over. The shuttle could be delivering a satellite into space, or maybe it's on a resupply mission to the International Space Station. Each mission is unique, each has its own set of challenges and rewards. With the shuttle in orbit, the possibilities are endless, from satellite deployment to space station resupply missions. And that's just the beginning of the adventure for our intrepid space explorers. From countdown to orbit, a space shuttle launch is a marvel of human ingenuity. It's a journey that begins on the ground, with the meticulous preparation and the suspenseful countdown. At 0, the ignition sparks into life, providing the thrust necessary to lift the colossal vehicle against the pull of gravity. The liftoff is a spectacle of raw power and precision engineering, propelling the shuttle into the sky. As the shuttle ascends, the solid rocket boosters, having served their purpose, are discarded to fall back to Earth. The shuttle, now lighter and more agile, continues its ascent, powered by the orbiter's 3 main engines. Finally, the shuttle reaches orbit, a gateway to the cosmos where it can perform its mission, whether that's scientific research, satellite deployment, or construction and maintenance of the International Space Station. Next time you gaze at the night sky, you'll have a deeper understanding of the journey a space shuttle takes to reach the stars.